Hi, in this video we will start learning about rules of differentiation, and we will have 4 rules that will help us to find derivatives of functions faster and better than just computing the limit. Let me recall where we are in this whole process of finding derivatives. Well, what we learned that if we start with the function, then we have this limit that if we compute it, and if it exists, we called it the derivative of function at that point. Yes. The derivative of function at that point, we learn, for example, geometrically has a nice meaning. It is a slope, the slope of tangent line, or the slope of the graph. Well, we had before. Now, the process of going from f to f prime, which we call the differentiation. This is a very important process, and well, it actually gives us a very strong tool that we will use later on in this course and everywhere. Basically, without derivative is not life is not possible these days. Well, if that's such an important thing, having a cumbersome definition like this is not a good idea. So you have to take this limit, or even for the simplest functions, this would take forever to compute that. What is the solution for us? Well, people have computed some of the cases and called them rules of differentiation. Using those rules, we get a toolbox of differentiation rules that we will use to find derivative of more general functions. Let us start then learning about these tools. These are important ones. The first one is called the constant rule. It's a simple rule. It says that if you're trying to find derivative of a constant, C is a constant. By the way, ddx is another way of writing the derivative, yes. This derivative is always equal to 0. No matter what you put for C, this is going to be 0. Derivative of constant is 0, which kind of makes sense also in the setting that this guy is, well, the slope of the tangent line to a horizontal line. Yes, that's a line itself, so that's why you get 0. For example, you see that derivative, if I have the function is equal to c, well, what is c? C here for me is 3. Then the derivative of that function at that point is going to be just 0. If the function is, say, pi is a constant, like 3 is, like any other number is, yes? The derivative of that is going to be 0. And so on. So we will use this over and over again. But that's not enough. We need to add more tools to our toolbox. The second rule is called power rule. Well, there's another version of power rule which we will learn. This is just simple power rule. What does it say? It says that what is the derivative of x to the power n? How do you find that? This is what power rule says. The power you see there, it will become constant multiple. Then x to the power n minus 1. That is the derivative of x to the power n. Let me put this one in the box. Let me see if this time this will work or not. Okay, yeah. So the simple power rule says just derivative of a function x to the power n is n x to the power n minus 1. So let us start doing some example. If f of x is x squared, then f prime of x is going to be, see, n here is 2. Yes, and 2 will come up front. This is what it says. Then x to the power 1 less than the original power. So this is 2 to the power x to the power 1, which is just 2x. How about, for example, f of x equals to, well, root x. How do you see root x as power? Well, this is x to the power half, isn't it? So x to the power half, how do you differentiate? This is the derivative, the power rule. X, f prime of x is, well, this is derivative of x to the power half. And that gives us half comes up front. X to the power half minus 1. And this is just half of x to the power negative half. Let us just write this thing in a little better way. This negative power, we can take it downstairs and write it like that. And we know that root x to the power 1 over 2 is root x. So we have 1 over 2 root x. What is derivative of 1 over x? Well, 1 over x is the same thing as x to the power negative 1. We know that. So then as the derivative, we have basically derivative of x to the power negative half, which negative 1, the power comes up front, x to the power 1 less than the original power. This is negative x to the power negative 2. Well, we can take that downstairs and get rid of the negative sign in the power. Well, that's it. X to the power negative 1 over x to the power 2. Let me just add one more. This is nice one. F of x is just x itself. And you know that x itself is x to the power 1. So the derivative of x with respect to x is 1 x to the power 1 less. Then this is just 1 x to the power 0, which is just 1. Well, you can use always these rules, but for these three things, I suggest that you keep in mind these ones as separate. So let me remark. Better keep these ones in mind as the rules, as something that you don't need to go back to power rule to do it. First thing is that the derivative of the function x with respect to x is 1. The second one is the derivative of 1 over x is negative 1 over x squared. And the derivative of root x is 1 over 2 root x. Well, these three things are nice to keep in mind for later use. Yes, so that's the simple power rule. But we need to have more rules. This is the third one. It's called the constant, not just the constant rule, the constant multiple rule. What does constant multiple say? It says that, okay, if you have a function, you multiply it by a constant c, find the derivative of that c times f of x. This is a function. This derivative is equal to c times f prime of x. That is called constant, that is called constant multiple. So the constant multiple doesn't change the derivative in a strange way. It just comes out. That's it. And well, let's do some examples. If f of x is 3 times x squared, what is the derivative of f? Well, in this case, we are finding the derivative of 3 times x squared. Constant multiple rule says 3 comes out. And we have this thing, x to the power 2. Well, now here you can use the power rule. It will give us 2 times x to the power 2 minus 1. So this is 3 times 2x to the power 1. I can write just x, and this gives us 6x. What else? I can have something like, let me change the names a little bit. Gx is equal to, well, negative 2 over root x. Maybe the third root. Okay, so this is, we are trying to find g prime of x. This is d dx of negative 2 over the third root of x. And this is the same thing as negative 2 times 1 over the third root of x. This comes out. This is the constant multiple rule. Negative 2 times d dx of, well, what is x? 1 over third root of x. This is same thing as x to the power negative 1 over 3. And x to the power negative 1 over 3, you can apply the power rule. This, the power comes up from, becomes the multiple. And then x to the power negative 1 over 3, 1 less. The final is negative 2 times negative 1 over 3 is 2 over 3. And that gives us x to the power negative 4 over 3. Well, you can play with this thing and write it as the 2 over 3 times the third root of x to the power 4. Let us do one more. Something like h of t equals to just t over, say, 3. And we want to find h prime of t. It means that find the derivative of t over 3 with respect to t. This is how we write that. And well, this is, we can write it as 1/3 times t, and by the constant multiple, this comes out. And we know that the derivative of x with respect to x is 1. Derivative of t with respect to t is also 1. So in other words, I'm using the power rule here. And that is 1 over 3. And you can do more of this work using the constant multiple. But still we need more and more rules. What is the next rule we need to cover here? It's called the sum and difference rule. What is the sum and difference rule? It says that what is derivative of sum of two functions? Sum of two functions, you find the derivative of each one and then add them. Derivative of sum is sum of derivatives. What about if you have differences? Well, differences also works the same way. Derivative of differences is differences of the derivatives. So let me just put this in a box as our new rule and start doing some examples. Example, find derivative of f of x is x squared plus 4. What is this? Well, I have to find f prime of x d dx of x squared plus 4, and this is the sum of derivatives. And the first one is the power rule, 2 x to the power 2 minus 1. The second one is constant rule, the constant rule. The derivative of every constant is 0. So you get 2 x to the power 2 minus 1 is x to the power 1, which I can write just 2x. Another one, g of x is 3x to the power 4 minus 2x. Then, well, we have g prime at x is derivative of sums, derivative of differences of two functions. I'm trying to write different forms of notations such that you learn these different notations meanwhile that we are learning the rules. Here, two functions, the difference of two functions. So you can differentiate each one and then subtract. Here now, this is constant multiplied to x to the power 4. So it will come out and then we multiply to x to the power 4. The other one is the constant multiple again. So this can also come out as the multiple. Now we have the power rule, yes? So x to the power 4 is 4, the derivative of x to the power 4 is 4x to the power 4 minus 1, which is 3, minus 2. Derivative of x is just 1. So this is 12x cubed minus 2. That is the derivative of that function. Okay, and this way basically you can find derivative of all polynomials. Yes, you can, any polynomial one gives you, you can just go ahead and do power rule and then you find all them. Let me do one more example before we go and finish this. H at t is equal to 2t times t squared plus t. This is, we are trying to find derivative, but the function is in terms of t. So everything you replace x's by t. That's what it says. So here, when you want to differentiate this function, 2t t squared plus t, right away you notice that there's a product here. I don't know yet, we will learn very soon. I don't know yet how to differentiate a product of two functions. Again, yet. We will learn it. But at this stage, I can first expand this one over that, distribute it. So this will be 2t cubed plus 2t squared. And now we have a polynomial, and go ahead and find that one, d dt of 2t cubed plus d dt of 2t squared. This gives us the constant rule comes out, constant multiple rule, yeah? And another 2 here, d dt of t squared. Then derivative of t to the power 3. 3 comes up front, t to the power 1 less, plus 2, t to the power 2, 2t to the power 2 minus 1. Now we can have 6t squared plus 4t. The derivative of that guy is what we found here. So this gives us basically first rules of differentiation for us. We will add to this toolbox specifically two more things: how to deal with the product of two functions, that's called product rule, and quotient of two functions. That will come in the next section.